there's a multiplier inside. So it's really a horizontal stretch of 3. So sometimes you need that, sometimes you don't. Just depends on if they give you the right starting point or not. You know, if they have two graphs with the same starting point, in this case, H and K is a -4 and a -3. If that's the same on two different graphs, you got to know that I'm pulling on the graph. So -4, -3. This one's -4, -4, very inaccurately, right? For B, so that's not right. A is not right because it's a -4, -1. So we got to keep looking. C has got -4, -3. Even though it's not very perfect, it is what it is. D is incorrect because it reflected, and there is no reflection on our transformation. There's no negative multipliers. So -4, -3. And let me see, for number 11, we do not have to write about the domain and range. So you want to make sure when you, sometimes they ask, sometimes they don't. So yeah, I'm guilty. I don't read the problem very carefully. So read it carefully to make sure you answer it completely. Welcome to the ACG practice, right? Okay, so here we are. We've got a horizontal stretch again, but we also have a reflection across the y because that's negative multiplier. Flip the fraction, what is it, 3/2, and then reflect across y. My h and k is +1/2, -2. You should be able to, and these are marked by halves. So you look half over, 2 down, and reflect across the y. So this one is reflecting across the x. Tricky, huh? So when you reflect across the y, you go from pointing to the right direction to pointing to the left direction. So I go 1/2 and negative, is that right? That one's -3. Okay, this is 1/2 and +2. There it is. +1/2, -2. So that one is really a challenge to find. Many similar graphs. So that we reflect across the y-axis because the multiplier is inside. And now we write our domain. So if I look at this graph, my x values are getting less. So I go less than or equal to 1/2. I use h, but I have to go less than or equal to. That's a challenge, you know, on these. Which way do we go? Which way do we go? And just use your graph. Use your transform graph to see. See, my x's are going to the left, so they're getting less. Now, how's my y's going? They're still going up. So my y is going to be greater than or equal to my k, which is -2. So if you have that similar story that I did, then pay attention to the inequality signs. You'd be wrong. If you get it wrong, it's wrong. Okay, so make sure you're noticing those details. Boy, that was tricky, tricky, tricky one. Very tricky. Yeah, this one would have fooled me. Hopefully, so tread lightly. Maybe need more time on 12. So when we're done talking here today, everybody should have your 10-2 to turn in. You're paying attention. Yay. Okay, this one's back. Oh, yay, no fractions. Don't be afraid of fractions. Fractions are just numbers. That's okay. They're just a place in the thing. algebra ready for all numbers. So I'm glad they invite fractions in this story. Okay, the multiplier side, so vertical stretch. So I'm pulling it like pulling on my curve upward. And the A number doesn't flip, it's just 3. H and K are -4, -2. So no reflection. My square root function, my fountain of youth, will be squirting higher, but still in the same direction as my original square root function. And it will be beginning at -4, -2. So this one's -4, +2. Tricky, tricky. B is -4, -2, but it reflects, and we didn't. C is -4, -1. D is it. D is the diamond for me. -4 for my x value, -2 for my y value. You guys hopefully have gotten used to these graphs where the scale is on the side instead of next to the number line. That's a challenge. Okay, I think this one does not need the domain or range. Make sure you use your H and K if it's not like mine, but it should be similar. Modeling. Love the modeling. Any problems? Any doubts? It's okay to doubt. Just want to get them relieved. Okay, this guy, you get to create your function. That could be a test question. And we get the H and K obviously from the starting point right here. Notice the scale, it's by halvesies. So I got to be careful what I count. H is 3, K is 1. Remember from other lessons when we had to drag and drop, you don't change any signs. You put what you see. Okay? You don't take any reflections. You just write what you see. So here, this is 3, 1, and this goes down 2, run 1, which is down. It really goes down 1, run a half, but if you go down 2, run 1, that's an easier, idea to see. It could be down 1, run a half, but what's a reciprocal of half? You still get -2. So either way, this is where it goes in for 1/b. Okay? You go from the marked points. If you don't use their marked points, you won't get it right. This one is H and K. Now I just drag and drop my found values. So H was 3. Don't change any signs. K was 1. And I went down 2, run 1. And you are done with number 14. Okay? Please ask if you're not sure where in the world did you get that number. Square root functions, we love them. Part of the story. In construction, in commerce, in science, in technology. It all happens. Crazy, huh? Yeah, it's a multiplier inside, so that's why it went from pointing right to pointing left, so you know it's a negative. Just take a bird's eye view of what you just did. Just think about it. Just let it settle in your brain a little bit, then you'll be able to, solve problems you've never seen before. Okay, all I have to do is count. These are ones, so that's nice. Up 1 over 2, so that is a half. For my multiplier, I did my rate of change first, How fast is this curve growing? Up 1 over 2. But since it's a square root function, it's not a straight line, so it's not the slope. It's just the rate of change as you take the square root of a number. Okay, my x value is a -1, and I don't change the sign on it. I put it what it is. If you don't put what it is, then you're going to get it wrong. Okay, so are you listening? Then my y value out here, it is 0, and that's a choice. And, that's kind of awkward, but at least you can see what h and k is. So I will give you the graph, and you'll get to choose the function. So how do you know it's this one? Well, the h and k will help you the best. And if you have to, you can think about this. This is a horizontal stretch of 2. So instead of rising 1 by 1, it's rising 1 by 2. So it's pulling sideways. Watch the garden grow, right? That's what you call a minimalist garden right there. A dot in a line. It's not even a line, it's like a curve. Okay, A's outside, but that doesn't matter. All we do is count from the beginning of the square root function up 4, run 1. So I'll get that out of the way. That's the most, for me, that's the one that's most confusing. Is where did you get that from? Because from the point that began the curve to the designated point that they gave you, they did that on purpose so you could see the change. If it was a normal square root curve, it would just go like this. But it had a vertical change of 4. So instead of going out slowly, it went up quicker. Okay, what is this x value? Right here in your face, you see that -3? Don't change the sign. See that -6? Don't change the sign. H and K. We are empowered by H and K. Okay, the last one's just an A. So it goes, this one's tricky because the units are 1, so I'm just going down a half, run 1. So if I take down a half is -1/2, I divide it by 1, I still get a -1/2. So down a half is negative, run 1 is still -1/2. Okay, H splits the difference here, so it's a +1/2. That doesn't happen very often when you use this, the number in its opposite. So, and I checked it, and we're right. And then my K is going up 1. So Mathlish it is. Turn it in. You're a winner.